Definition: if the limit of the function is plus minus infinity when x approaches to a from the left or and from the right, then x equals a is a vertical asymptote to the graph of the function f(x). The limits can be infinite only if x equals a is not in the domain of the function. If x equals a is not in the domain of the function, the graph of f cannot cross the line x equals a. It is enough that one of the two limits is infinite for the graph of f to have a vertical asymptote. Example: fx equals 1 over x minus 3. The domain of this function is x cannot be equals to 3. It means that we have to check for a vertical asymptote at x equals 3. We have to take the two-sided limits. The limit from the right, again, I would like to recall, it's 3 plus, so it's almost 3, just a little larger than 3. And that's why 3 plus minus 3 is a very, very small number, but positive. And again, as we did in limits and infinity, we will write 0 plus when the number is very, very small, almost 0, and positive. And we get here 1 over 0 plus, which is infinity. We have definitely this case, and we can conclude that x equals 3 is a vertical asymptote. We're also going to take the other limit. X equals 3 is already an asymptote, but we still want to evaluate this. And again, I would like to recall 3 minus is almost 3, but a little smaller. And we get that 3 minus minus 3 is a very, very small negative number. And we are going to write 0 minus for that. And we get negative infinity. In this case, we have that, and we conclude that x equals 3 is a vertical asymptote. We already know that, but if we need to sketch the graph, we really like to know what happened at 3 plus and 3 minus. Definition: if the limit of a function equals b when b is a finite number, when x approaches infinity and or minus infinity, then y equals b is a horizontal asymptote to the graph of f(x). These limits are the end behavior of the function. They describe what happens to the graph of f in the extreme ends. It is possible to cross a vertical asymptote many times. It is about x at infinity and minus infinity only. Example: find the horizontal asymptote or asymptotes of the graph of the function f(x) equals 7x plus 9 over square root of x to the power of 2 plus x. To find horizontal asymptote or asymptotes, we need to take the two limits of the function 1 to infinity and 1 to negative infinity. Let's start with the easier one. Here we don't have a lot of complications because x is positive. In the radical, we are going to divide everything by x to the power of 2, and outside the radical, we are going to divide everything by x. Simplifying. And we know that the limit of these guys is 0. And we get 7. Now let's do the more complicated limit. Is the limit when x approaches negative infinity. The complication here, again, I would recall that now the square root of x to the power of 2 is absolute value of x, but absolute value of x now is negative x because x is negative. It means that in the radical, we have to divide everything by x to the power of 2, but outside the radical, we are going to divide everything by negative x. And we get this. We will simplify again. And don't forget, this is 0 and this is also 0. And we get -7. We conclude that y equals 7 is a horizontal asymptote at infinity, and y equals -7 is a horizontal asymptote at -infinity. It sounds maybe surprising for you, but I would like to tell you that many functions has two different horizontal asymptotes, one in infinity and one at -infinity, and they don't have to be the same. Here is the graph of the function f(x), and you can really see the two different horizontal asymptotes at infinity and -infinity. Example, f(x) equals 1 over x minus 3. At infinity, we get just 1 over infinity, which is 0. We get that. And we conclude that y equals 0 is a horizontal asymptote, at least at infinity. Now let's take the limit at -infinity, and we get also that the limit is 0. In this case, this graph has only one horizontal asymptote, y equals 0. This was pretty much expected. This is a rational function. We expect these two limits to be equal, but this is not true for most other functions. As you saw before, it is only true in rational functions. Rational functions have only one horizontal asymptote, if they do. To find all vertical and horizontal asymptotes of a function f, this is what we have to do. It's really finding the domain, and then from the domain we can find the vertical asymptotes. And if you take the limit of the function at plus minus infinity, you will get all the horizontal asymptotes. Pay attention. It depends also on the domain, because some functions, for example, like logarithmic functions, their domain is only positive numbers, so you cannot take the limit of the function when x approaches -infinity. So the domain is a major issue when we are looking into asymptotes. For example, let's see this case. The domain is x is not 3. For the vertical, we have to take the two-sided limit of x approaching 3 from the right and from the left. And we concluded that x equals 3 is a vertical asymptote. And I want to also recall that we also did this. We found the horizontal asymptotes by taking those two limits. And we get that y equals 0 is indeed the horizontal asymptote of the graph. Here is the graph of 1 over x minus 3, and you can see this in your own eyes. Example, find the asymptote or asymptotes of the graph of the function f(x) equals e to dx. Again, we have to notice the domain. The domain of the function is all real numbers. It means that automatically we cannot have a vertical asymptote. But we have to focus on the end behavior then. We know already that the limit of phi to dx when x approaches infinity is infinity, which means that at infinity there is no horizontal asymptote. But the limit of phi to dx when x approaches to -infinity is 0, because this is like e to the -infinity, which is 1 over e to infinity, which is 1 over huge. So y equals 0 is an horizontal asymptote, but only at -infinity. Please remember that the limit of phi to dx when x approaches infinity is infinity, but limit of phi to dx when x approaches negative infinity is 0. Also, the limit of e to the negative x when x approaches infinity, if you notice, is exactly like the limit of e to dx when x approaches negative infinity. It is 0. And the limit when x approaches to negative infinity of e to the negative x is infinity. Let's now revisit the function f(x) equals e to the x and apply the chart. The domain is all real. That's why there are no vertical asymptotes. What about the horizontal asymptotes? The limit of e to the x when x approaches infinity is infinity. It means that at infinity there is no horizontal asymptote. But this limit is 0 at negative infinity. So y equals 0 is a horizontal asymptote only at negative infinity. Here is the graph of the function y equals e to the x, and you can see very nicely that there is only horizontal asymptote y equals 0 at negative infinity.